Можем начинать, да?
Да.
С нами на связи Андрей Данилов, презентует свой доклад из солнечной Испании. Андрей расскажет про третье поколение инструментов CI/CD и почему же все-таки стоит тестировать наши пайплайны. Андрей, you can start your talk.
Right. Hello, everyone. Thanks for joining me today. Even offline, online. No, it's an interesting thing, and I'm happy to see faces again behind the screen in my talks. So I'm Andrei, and I'm based in Barcelona. I'm originally Romanian. And about myself as a professional, I always enjoyed the creative side and data-driven of looking at technology. And through the different things that I do, like blogging, talks, I hope that many of IT professionals out there get inspired to change things in their organization in new and creative ways. In my free time, I like cooking and everything that is going around these gastronomical experiences. Like, for example, craft beer, I include also there. And now I'm also studying the Master of Artificial Intelligence. And that's the reason I'm not there, because I have an exam on Monday. And before we start, you might ask yourself, like, this guy's name is Andrei Danilov. Why is not he speaking Russian to us? Like, why not? It's like, I'm actually quite sad that I don't, because half of my family is of Russian origins, like old Russian origins from the 17th century. I believe in English they're called Cossacks, and in Russian something like Kazaki. It's like from that area. So I'm a bit proud of my roots, but I still need to learn Russian. Now coming a bit back to the talk, I hope that by the end of it, we all get a good grip of these three topics here now. Yeah, and the CI tools are not so old as the floppy disk, but it's very important to understand the history of where they come from. And it's and that's related to why we haven't tested them before, no? And we also dig a bit into a very scary topic, which is testing these CI pipelines. And we are already engineers, we have superpowers, so we are prepared to test them. So you will see nothing new, nothing spectacular, straight to the point. But before we start, I would like to know a bit more about you there in the audience. So have you used any tool before Hudson or Jenkins in any project that you were involved in? Raise your hand if so. Okay, very interesting there. There are some people with experience over there. Because Jenkins and Hudson is the ones that we mostly remember, because they are like one of the revolutionary one. We will see it during the talk. It's very interesting. So, and this is what we're going to talk a bit in this first part of the presentation. How did we arrive at the modern tools that we have there now? So it turns out that the first time some engineers thought about continuous integration, this very fuzzy concept, was around the early 90s. And most probably as a 90s kid myself, I'm not the person to speak to you about history so much, or not yet. But they started, we can basically agree that all of these CI tools started with basically a set of scripts. Now, some bash scripts or in whatever technology that they were step by step executing the application, running some sort of validation, and they were putting it somewhere that is accessible to everyone. And while looking for a previous version of something that is not Jenkins and Hudson, I found this, that is cruise control. It was very hard to find this image. And this one was one of the oldest kind of tools for CI that was developed. I think it was developed by ThoughtWorks and around the 2000s. So this is when the CI tools that we like massively used nowadays, they come from. And all of these previous efforts like cruise control, all of these scripts, led to highly adopted first generation of CI tools that we all know. Like we all recognize these logos here, no? And we all might even use some of them today. These tools are revolutionary, and let's see what kind of characteristics they have. So the idea behind all of these modern CI tools is that you create jobs, no, that perform certain operations like building, testing, deploying, and so on. And then these jobs, you put them together, no, and you create a CI/CD pipeline. These tools are also extendable by a certain number of plugins that were not initially developed by the people that developed them. For example, if you remember the Chuck Norris plugin, back in those days when Chuck Norris was a super funny meme in the internet, now it's not anymore. And it was telling us, like the build failed and with a very angry face, and you didn't want to fail the build because of it. So it was like kind of motivation. And the approach was to configure everything through the UI. So you go with clicking and you were basically configuring your CI pipeline. And it was pretty straightforward to use, actually. No, like it was not rocket science. It was easy, but the main drawback was also that you needed to do maybe a lot of copy paste. Like if you had a bash script that was kind of your pipeline, you're developing it local, then for sure that's another environment where Jenkins exists. You paste it there, it's missing some packages, all of these things. So it's a bit painful. And if I had $1 for every time I heard, like we need to clean up Jenkins, it has a lot of old things and stuff like this, I would be definitely very rich. So the way that these tools were configured, were designed, or were making it impossible not to end up with a lot of maintaining and maintenance work. And these tools were generally hosted on premise by the organizations that were using them, or not in the cloud. And there was no reference of the code in the code of the CI tool. The code didn't know that the CI tool exists. It was the other way around. No, the CI tool knows that the code is in some repository and was taking this thing and doing things on top of it. These tools also were kind of handling some small amount of logic, but very low. They were more focused on doing the job of building, testing, deploying. Nothing very particular, no. So this is the general overview of what the first generation were doing. Okay, now that we became very melancholic, no, it's good to be melancholic. They were very good tools, but they definitely could be improved, and they were improved. Before we continue, I would like you there in the audience to answer me another question. Are you using just one tool of CI in your project or multiple? If you are using multiple, please raise your hands up. Okay. I see many of you are using just one tool, or maybe it's a small delay. Okay. That's interesting. For example, in my project, I usually use multiple ones because you use it for different kind of things. It's better to use one, much easier. Okay, then the second generation of tools came in, and it improved a couple of things. For example, you already can recognize Travis, Circle CI. They're a bit more modern. We use them today, and so on. For example, they had this auto discovery feature, which basically you have something in your repository, like YML file or whatever, and based on that, the CI knows how to do things. So this was the advantage. No, we were having a kind of a pipeline as code ready. And what I consider also smart, there were some tools that even though if you don't provide this YML, they already know how to do the basic things for you. Like for example, test or build and whatsoever. So for example, if you had the Gradle kind of project, it will do a Gradle test, Gradle build, and you're done. No file needed. It was smart from this end. They're generally cloud-hosted solution, although some of them are also on-premise in the beginning. So it's an improvement into there. And this like lives in every project. This was this is like kind of a disadvantage, and but it's confusing because I also said no, pipelines are living as code, so that's amazing. Why is this a disadvantage? Imagine that you work in an organization that you have, I know, hundreds or thousands of repositories out there. No, it's very hard to get a good overview of what are the processes for your CI/CD pipelines, and it's very hard to modify all of them if you want to make a small change. So this could be improved as well. And we have the configuration inside the repository, but the tools are still outside. It's not fully integrated. No, it's a separate tool that still does things on it, on your own thing, and you might get some downtime from one tool, some integration flows that maybe they don't work very well now. And they also have some a bit more logic here. So for example, Typeform, we send after deployment, we set some events to actually improve a metric that is deployment frequency. And we send a different kind of event depending on some parameters in the job. So this already is some kind of logic. And from my understanding, this is what are the things that the third generation of CI tools are trying to solve right now. They are trying to improve these topics. No, the third generation is still developing. It's all like still improving, but there are some solutions that already shape this generation and will define what will be actually the third generation in no time. So to fix, for example, the fact that I was saying, hey, it lives in every project. For example, a tool like CodeFresh is attempting to have like common or organizational wide pipelines that are controlled by some metadata. So one pipeline, for example, to deploy to production, but with various logic depending on the things that they are. For example, if you're having a project with a certain Java version, it will do a certain thing. If you have a certain Selenium version, it will do it in a certain way, and so on. So you will have different outcomes, but you still have the same pipeline and the overview that you need to control a CI pipeline in a very big organization. Other set of tools are also trying to solve the problem of being very far from the code. So for example, GitHub Action, Bitbucket pipelines, etc. They say directly, I want to live next to where your code lives and nowhere far. No, I will be right there. And some tools help you also to build some reusable steps that can be plugged into your pipelines. For example, CodeFresh and GitHub Action. So these are small pieces of software that have some logic. For example, they can create an issue in Jira after deploying. They can send you an SMS at some point in the pipeline if the pipeline fails to, to release to production. No? And maybe you are releasing once per day during the night. This is very useful. Maybe at some point you want to send some files, maybe some test screenshots to an S3 bucket. No, you have also this. So they even created a community-backed marketplace. I just said that you can browse, choose whatever you need, and if it's not there, you can make it. And as you can see, the third generation of CI tools, it's aiming pretty high, and it's solving some of the problems of generation one. So very tricky question for you. Raise your hand if you have ever changed something in the pipeline and it just broke. All right, I think there is some people, but the rest who didn't raise the hand is not very honest. we all broke at least once. Cool. So nowadays I don't play so much board games, but you're wondering why I put this risk game here. Because for me, testing was always a game of risk. No, you don't do it if there's no risk. No. So if it didn't make much sense to test generation 1 because there were not so many things going on there. No, you build, test, and deploy. Not many things can go wrong. No, they were just sequential operation, and if there is a problem, there was just an infrastructure thing, missing package, or I don't know, just normal failure because the whatever you are trying to do failed. And you might say, I'm confused. What makes this generation 3 a bit different? Let's go through 2 examples. So I will make you understand tomorrow on that. So let's look at how a common organizational pipeline would practically behave. This is an example that it's based on what we have at Typeform, and it's something that we are kind of also seeing right now. We have defined a YML file that is somewhere in each repo, on the first code base. Imagine that I'm explaining that this is a web app. It's written in React with JavaScript. I have some functional tests with, I don't know, WebDriver IO, and the canary strategy to release this is, if this is successful, it's 10%. This metadata is configurable, and you can add whatever your pipeline knows how to read. So, for example, if you add a new field, a new parameter in the pipeline, you can also add it in the YML. Similar to Codebase 2, you have another type of project, maybe it's written in a bit older Angular, and has some functional tests with Cypress, different canary strategy, and all of these files tell the pipeline how to do, and the pipeline will do it. So this means that the pipeline already has some small logic inside it, knowing what to do in which cases, and it's able to do at least a small amount of decision making. So imagine we release a version 2 of this pipeline on which both of these code bases will rely, and is there any risk to potentially break one of these pipelines? Yes, there is a risk. And the funny thing is that you will realize that you broke something maybe very late, because maybe your second project that is more legacy, you build it from time to time, and you find the problem in the pipeline much farther away in time. So you're yourself in a complicated situation. Could some testing help with this? And we all are here because I think we believe testing does help us with a lot of things. So you'll say, but generally pipelines are simple. No, we have just build, test, and deploy. And you are generally right, because this is the first generation kind of pipelines that we are used to. But nowadays, they are not so straightforward. They are a bit more complex. For example, after building, for example, you might want to have an automatic decision to decide which level of test to run, just unit or just end-to-end. Is the full set of tests or just the concrete or minimal set of tests that you want to run? For example, before deploying, you might want to know if, for example, if your company has a code freeze moment, for example, maybe Christmas or maybe an important event in your country, maybe you want to be able to pause that deploy until this code freezes end. This is some logic over there. For example, is there a Jira ticket in the commit message? Because then I can go to Jira and maybe change the status in pending deploy and so on. And maybe after deploy, we want to flag this. If this is flagged as an important release, we want to say to customer service that, we have an important thing going on. There might be problems and whatsoever, and let's email them so they know if people complain. They know much faster to come to us, and maybe we roll back or things like that. And maybe, as I said, the previous example, which kind of software did I deploy? And based on this, I can send the deployment frequency event to some database. And all of this is logic. And I ask yourself, how many test cases do we have here to try? How many combination of this do we have? How many things can go wrong? A lot. And there is a risk associated with not testing it. So, okay, why do we need to test again? we have a higher risk of breaking the pipelines and having them broken in moments that we don't know and we are not aware. Our deployment pipelines are like a production tool. No, imagine we need to do an emergency deploy and we have a failing pipeline because of a change of functionality of that pipeline. No, and this is stopping a critical release to production. This is not ideal. So okay, let's unit test the pipeline. I think that's all right, and I hope you already do some kind of unit test in your project, but also if you are developing similar things. But we need to do something a bit more. So let's come back to this common pipeline to understand even better my point. Let's imagine that this piece of software that I highlighted here with yellow or orange, depending how you are seeing it, it's developed by another organization because it's taken from the marketplace. No, it's from the GitHub marketplace. It's like, it's some simple code. Let's plug it in our organizational pipeline. No, and maybe this company or this individual that made this doesn't care too much about best practices or have good quality process or culture in mind when doing it. And they push a version 2 of this. No, and you say, this no code cannot give us any problems. No, it has never created in the past a problem. Why would create now? But suddenly somebody tries to release and the pipeline breaks for them because it's something wrong in this small module that we are just plugging in our pipeline. And then you know how this goes. Everybody's trying to release in that very moment and you're blocking all the company. That's not very nice to handle. And I've attended some long time ago a talk, and they were mentioning something like this, no? That when the complexity of the infrastructure rises, the usefulness of testing early also decreases, no? And this is interesting. We'll see later how this is relevant for my talk, because this is something that I really like. I like ancient Egypt. I always was a fan of history. And I'm also a huge fan of the test pyramid. And we need a strong base of unit test and testing that you have there, but also we need a higher level of test to identify other possible issues our software can have with types of testing that happens a bit later on the later stage, and it's at a higher level. No? In this case, the software that we're talking about is our CI pipelines. No? We need to unit test it, but we also need somehow to be able to run this in a more controlled environment and test it that, wait, these kind of things could work. So you say, this is impossible. No, this guy comes here and explains, I need to do more testing, a new style of testing. I already have complicated stuff in my mind, like pact or contract testing or any other thing. And they are also not providing me a tool on how to do it. No? And they are telling me, it's also easy and you will know how to do it. And sadly, I'm this guy. I will tell you how to do it, and I will show you also kind of what tool you can use to do it. But before we continue, who knows black box testing? All right, nice. Then all the concepts that we will have in the next slides, it's pretty straightforward for you. You will get it very easy. So since all of you are pretty familiar with black box testing, the same concept kind of applies when testing high level, the CI pipeline. We finally need to give some inputs, no? And based on these inputs, abstract ourselves of what's happening over there and be able to check some outputs, no? That are the outputs of whatever happened with this software, no? So let's look at an example which I worked in the past. It's a commonly shared GitHub action in my company right now, and that can be a step on like any pipeline, no? And this is a small piece of software that connects with the Google Calendar and tells us in the moment of the execution if the calendar is busy or not, if it has an event in the calendar or it's free. So we have this GitHub action that we know that functionally does this. But we also know the inputs that are free variables. Two of them are more like a token and all of this configuration from GitHub. And the other one from Google, and the other one it's calendar ID. These are the inputs that we give. And the output is a boolean, no, true or false. If the calendar is busy, then it's true, no. If it's free, if it's false, no. And remember, this can be part of our huge CI pipeline. So let's test this scenario, no, that it's a happy path, no. If a calendar has no events in it, we will return a false after that. So what do we need to automate this scenario in a CI pipeline? First of all, we need to understand what are GitHub actions and what do we use for. So apart from being a fancy new button in like the bar on any GitHub repository, it's a way to automate workflows and pipelines such as testing, static code analysis, deploying to production, whatsoever. And these are YML files that are placed in GitHub workflows folder. And you can define different YMLs with the workflows that you want to perform. And inside this YML file, you can define different steps that you want to execute. And these steps needs to specify what GitHub action to use, no? And which is this reusable piece of software that we can either make ourselves or take from the marketplace, no? They have here, for example, the hello world example. And as you can see, this is not very different from how a Jenkins file will look right now. It's just a YML. Not complicated. But coming back to what we need, no? What do we need to make this happen, no? Definitely we need to have some test data, no? Generate these tokens and an empty calendar. So whenever I call this test, we will always receive a false. And we need something that will allow us to assert the output, no? We were saying that this will be a true or false. We need a tool that does that. I came up with a super easy proof of concept and a simple one that can do assertion. It's based on Chai, if you're familiar with it, and in the back to do some assertion. This is not complete, but it's easily extendable, and it's more of a proof of what you can do and how you can check. You can use any other tools. At some point in the end, I will also show a link to this so you can check it out, but also some links of other tools for other technologies that you can use to do the same. Okay, this I abbreviated GAT because GAT is in my adoption country Catalonia. It's the name for cat, and yeah, it has some. Also, I'll put some funny emojis. Okay, so this GitHub action that allows us to test, to assert, has three inputs. The assertion, no, for example, should equal the expected and an actual, no. You are very familiar with this kind of testing, so should be straightforward, no. And for sure, this is failing when this criteria is not met. So let's test whatever we were saying that we want to test, no? This is the test itself that will be a GitHub action in the pipeline with two steps, one for each one of the when and then that I've added over there. This is the when part. So in this part, this uses means that we are checking out and we are checking out the same repository I'm executing this on with the branch that is finally specified in the headers file. We will go into GitHub very shortly and I will show you that. The ID, I give this step an ID to reference it later because I'm using the output of this in the next step in the then, so I can check it out. And as you can see, I'm using some $sign and the brackets. This is my inputs, but my inputs are configured as secrets in the repository. And with that, I'm taking the secrets and I'm plugging it in my tests. And for the then part, I'm using the GitHub Action Tester that I've just saying you. If you are checking the uses part, and you can see I'm doing an assertion should equal. I'm expecting false, and then in the actual, I'm passing the output of the previous step. So this should be able to give me the whole picture of the test that I'm trying to build. So let's see this cat running in real. I will show you this repository. Are you able to see GitHub right now? Say yeah. Okay, nice. So this is the repository that I'm having. If I go to GitHub workflows, I have this test YML file that is set up like a pipeline. I put a name, even happy path returns false. I'm executing this in any push and in any pull request to the branch master. And then I'm also I'm configuring the test as a job. No, we are having here the first one. It's exactly the same as you are seeing, but I've added some extra fields in the. Don't worry too much about it. In the presentation, I've tried to make it as more simple as possible. You can do this with many other variables. If you configure more variables, then definitely you can do more test cases over there. And then you can see that the then side it's doing an assertion, expected, and the actual. How do we trigger this? Well, let's make a small change. And let's make a small change in the here in the README. We will commit, but we will create a new branch, and we will create a pull request. So by creating a pull request, what is happening right now, you will see that this is starting to run. Setting up the job. Nice. So you can see that we checked out, the scenario has run. This is initializing the current branch, so we can run the checks over the current branch. We are checking that there are no events, so we even print out from this small piece of software that we developed that the calendar is not busy. That's amazing. And then the output, you will see that this should equal. Then actual is also false because this is what is returning our previous step, and expected is false. So then the test is passed. This is it. So coming back to the presentation, what do we need to enable better the teams to be able to test CI pipelines? First of all, we need to increase a bit testability. We need somehow to make these pipelines have at least some inputs and be able to check some outputs. Outputs can be in the form as you just seen right now, a concrete output, but an output can be also like, hey, this S3 file was uploaded over there, and I can run a couple of checks over there. Or for example, I uploaded a new version of this in Artifactory. Let's check that. So we need to increase a bit the availability to check of these outputs of our pipelines. And definitely we need somewhere to test. Something like a discardable environment where we could run this and automatically maybe delete the things after we test with even a test repositories or a set of test repositories for that pipeline. And we also need to raise awareness into the testing community that this is a topic to tackle because this complexity is definitely rising of the pipelines. And as a testing community, let's also build more tools for this. GAT is something like a demo, not even an MVP of proof of concept, it can be used on GitHub Action. But what about more other and complex situations in a deployment pipeline? Let's try together to build something in this direction. And talking about tools, I've promised that there will be a list of tools that could help you to build pipelines with more quality. You will see that most of them are focused on being able to build that pipeline locally, and you can run this kind of, they will help you, these tools, to run that manually in your local. This is really a good step forward. They can also be orchestrated in like a series of scripts to make this assertion that they also make inside your local. And then there is this framework of unit testing for the Jenkins pipeline that I'm not sure if you're aware of, but it's pretty interesting to look as well at it. Even though it says unit testing, it's at a higher level of testing this at a higher level. So to sum up the session, let's understand all that CI pipelines are also software. And the complexity of this kind of software has raised, no? Because the tools and the environment we are living in and the situation we are living with an increased logic, it's making their complexity rise. And for sure, there is more risk of making a change in all of these pipelines. So let's be careful about that. And that's why it's a must to do this kind of testing nowadays. And we need something at a higher level, not just the basic, let's say, a small unit test on the small functions that that piece of software might use. That's all right, please do it, but let's do also something at a higher level. And there are some tools out there right now. Let's use them, contribute to them, and maybe develop new ones. And definitely let's work together to make this topic more heard and in the industry, and contribute to tools that we will end up using for this. So I'd like to thank you for your time today. Nevertheless, I would like your feedback. You can scan the QR code and provide me feedback in the form that I've prepared for you. If you want to get in touch, make sure that you connect with me via LinkedIn. And as well as if you want to check this GAT tool, this is the link for it. And now I'm open for all of your questions. Now it's your moment to speak.
Hello, Norris. Thank you for your presentation. It was really interesting for me. And I think in scope of the discussion, necessity of having such tests is not even discussable or controversial. Yeah, we really need it. And my question is more about test architecture. If we take a look at test pyramid, we can have, for example, unit tests or some little bit more high-level tests for our pipelines. And my question is, what is the level of abstraction we need to have in our tests for pipeline? What's the level of mockups we should use? And what about repositories? Do we need to have mockups for creating of them? So yeah, something like that.
Definitely, it's a very interesting question, and I've seen this working in different ways. I've seen, for example, for some cases, repository being spin up automatically by some kind of mock files that are present in like this test project, and then they are deleted. You can do that via, for example, the GitHub API, or even, for example, if you are doing it in Docker, setting some Git commands and being able to, push, a commit push and create the repository, and then definitely delete it. So that can be an interesting cycle to test your pipeline. Definitely any kind of mocks. So for example, will help you out because, for example, you have there this calendar thing that we were talking about. We were testing in real in a very high level, this can be mocked as well, no? And you can set up, I know, wire mock, for example, for it, and feed all of these things out there, no? You cannot depend always on you cannot know how third parties that you integrate, no, will react when your pipeline is live, and this is the challenge with any kind of software, no, even a web application, no. So definitely for being faster at releasing, mocks for the most stuff, no, and being able to have something more controlled, it's the way to go, rather than having a multiple high-level tests that is going to slow you down and maybe even complex to orchestrate. No. I'm not sure if this answers your question.
Thank you.